Hello, everyone. Thanks for joining us today. People are still joining the meeting, so we'll wait 1 or 2 minutes and then we can start. Okay, thanks. All right, thanks everyone for joining. We will kick off today's webinar. So your microphones will be muted unless you're invited to speak, and we welcome you to use the Zoom Q&A function to submit your questions during the presentation. We will then have time about 10 minutes or 15 minutes at the end for question and answer. Yeah, so we will be able to pick off the questions when it's during Q&A. Thank you. So we can move on to the next slide. Okay, so this is the agenda for today. We are now at introduction and house rules. We've been through that, so I will then also introduce our speaker for today shortly, and we will then have some Q&A followed by final announcements before we finish at 3 o'clock. All right, so let me now officially welcome all of you to the Green Roads webinar series for 2026. I'm Christina Chong and I am your moderator for today's webinar. We have some interesting sessions coming up, covering topics such as country-level climate hazard risk modeling, smart infrastructure, and climate resilient road design and maintenance manuals. So keep an eye out for these meeting invites in the coming weeks. For today, we are covering a topic that, well, has near universal appeal, has been talked about for some time, on how to create valuable products from plastic waste. Our colleague, Hussein Haider, who headed the project that we are going to be featuring today, from ADB, he is unable to join us, but we do congratulate him on a very successful project. The use of recycled plastics in road construction is often framed as a sustainability solution, removing plastics from the solid waste stream. But durability of the products remains the critical determinant of environmental and economic benefit of such an approach. So if the road is not durable, it's not a sustainable solution. This webinar examines how recycled plastics can be responsibly engineered into asphalt pavements. It will be focusing on a case study in Papua New Guinea. The session will explore the scale of plastic waste challenge, local capabilities, and government and industry support for such an approach. This case is taken from an ADB-supported project, and it will illustrate how durable design, proper processing, and collaboration can transform waste into resilient infrastructure and brings lessons from PNG for wider application across the Pacific countries. Our speaker today is Professor Filippo Giustozzi from RMIT University in Melbourne, Australia. He is a pavement materials and design specialist with over 18 years consultancy experience in Europe, the Middle East, Southeast Asia, and Australia. His consultancy portfolio covers the design and performance optimization of road pavements, environmental analysis, development, and implementation of polymer modified bitumen systems. recycling technologies for roads and construction waste, and the integration of sustainability into large-scale highway and airport projects. So very extensive experience across roads and pavements technologies. Filippo has also been engaged to deliver advanced pavement design, material characterization, performance-based specifications, life cycle assessments, and forensic investigations, providing technical guidance to contractors, bitumen suppliers, and road authorities on the optimization of mixed designs, durability, and cost-effective infrastructure solutions. He regularly provides independent technical advice, performance testing oversight, and constructability support on infrastructure projects worldwide. So with this very, very impressive portfolio and experience, we will hand over the virtual floor to Filippo for his session. Thank you.
Thank you, Christina. Thanks and good afternoon, everyone. Also, I would like to thank Michael and Ian for this invitation. And today my talk is going to be revolving around how to possibly manage one of the most famous these days waste streams, which is plastic, and how to possibly use that meaningfully into converting this waste into a recyclable future recyclable value for infrastructure, especially looking at Papua New Guinea, with a little bit of context given by other applications around the planet, including Australia, where I'm from. Before we start with the real presentation, I just wanted to put some introductory slide here showing you Papua New Guinea. Most of you might be aware of Papua New Guinea and when it's located, very close to the top tip of Australia, as you can see. And as many countries, especially many developing countries, the plastic issue has become larger and larger and larger issues year by year by year. So as of the latest statistics I was able to find, which was 2024 data, there are 285,000 tons of plastics that are generated annually in Papua New Guinea. Most importantly, 57% of it, which is quite a large amount, escapes into the environment. So some of this is being just reprocessed and sent overseas, but 57% still escapes into the environment. And particularly when it's out in the environment, about 126,000 tons every year are getting into the ocean, which is quite a large number. There are studies out there projecting that this will increase significantly because the population of Papua New Guinea is increasing, because the waste is not taken into consideration and recycled properly, or it's always dumped or burned or unmanaged. So this has generated a projection of up to 2.3 million tons of mismanaged waste plastic in 2035, by 2035. Now, this is not an unusual problem. Other countries such as Australia, we also have a big issue with recycled plastics and waste plastic in general. Now, the problem is waste plastic, but some of the countries have developed a system to recycle this waste plastic in a meaningful way. And plastic is not the largest stream of waste that a country can generate. Organics is one of the top. In Australia, we do have a lot of construction and demolition material. For instance, metals, glass, there are several streams, but plastic is definitely one of the worst because of the difficulty that people have in recycling it. Plastic is not just one type. There are many types of plastic. Each one is different from the other. And in many common products that we find at the grocery shopping, during grocery shopping, you will see that plastic is not a single type. It's a mixed type of plastic. There are different layers, for instance, in a bag of chips. And that makes recycling very complicated. So in other countries, I was about to say, although they have the same issue, recycling is still developed. It's considered a priority for the country. And the country has invested or regularly invests money in recycling infrastructure. This is not the case for Papua New Guinea, where we do have almost zero domestic plastic recycling facilities. If you think about last year, only 455 tons were exported overseas for recycling. Consider the total number of 285,000 tons generated. Also, consider the fact that the waste management system is not great itself. So when we are collecting waste in Papua New Guinea, there is a collection that only covers approximately 13%, 13% of the households. That means that waste is not even collected in many other parts of the country. And also, that's something that you can easily figure out if you happen to travel to Papua New Guinea. You can find waste pretty much everywhere, especially in the main cities. There are over 25 unregulated disposal sites, and there is limited formal facilities, but the majority of waste is usually collected and then dumped in landfill, where sometimes is also burned or generally unmanaged. And this data is at the bottom of the slide is related to a 2025 Papua New Guinea waste data profile. You can see all the references at the bottom of the slides if you're interested in the full reports. This is a slide, and the one that comes after is also similar to this, representing what the problem is or was at certain sites in Papua New Guinea. Some of these sites have been remediated now, so they do not look like they looked before when this photo was taken, but it gives you an idea about the general problem around waste, but also about waste plastic. It's not just a waste that contaminates the land, it's also waste that gets into the infrastructure, into the sewage, into the culvert, into the curbs and the channels. So every time there is a rain event, for instance, and in Papua New Guinea, you got the wet season, which is quite important, lasting several months. The importance of sewage system, the importance of curbs and channels becomes very significant. So the fact that they're all clogged with waste and plastic, it's a waste of resources because, as you can see, man needs to go on the ground and unclog the infrastructure, but also a contamination of the land itself. So just as a summary for the waste management in Papua New Guinea, we know that the plastic waste itself accounts for about 13% of the total waste generated in that country. Considering 10 million approximately people living there, that means about 134 kilos per person per year is generated in terms of waste. Now, there is a projection of population growth of 3.1%. So that means that the waste generated is also going to be higher, and it's projected to surge by 1/3. But most importantly, what we've seen is that the facilities to recycle are almost non-existent. And it's recycling, if there is any recycling, is primarily done by private companies at a very small scale today. But the situation is improving, and I'll show that to you in a second. And also the waste management system, it's also not facilitating these recycling efforts because most of the waste goes to landfill and there is no separation of the waste. So you got the glass going together with the plastic, going together with timber and construction demolition material. So the separation, which is probably the most fundamental part of waste management, is not really covered in Papua New Guinea. Now, this slide might look confusing, but if you follow me, you can get through it quite quickly and with a good understanding of what it includes. Now, if we start from the left-hand side and you just focus on the bottom half of the slide, you will see that there is an industry and a few shops there. So that's the place where, together with the households, that's the place where plastic waste is generated. Shops, industry, households, they generate plastics. They generate waste in general. Now, overseas, in developed countries, you will see that there are different colored bins for different types of waste, meaning that you can get the green for the organics and the yellow for the recyclables, so on and so forth. So the plastic is kind of sorted or well separated from the get-go, from the beginning. each different color bin is then collected by a different color track or a different track. And the track goes to what is called a material recovery facility. The material recovery facility is the place where the waste is further separated and it's baled altogether into these big blocks that are easy to transport. And each and every truck with different streams of waste goes into a recycling facility. And you can have so many different types of recycling facilities: a glass recycle facility, a glass recycling facility. You can have a plastic recycling facility. You can have different types of recycling facilities. In the recycling facility, streams of waste are getting recycled into something meaningful. So it's not unusual to find old plastic bottles to become new plastic bottles. In Australia, most of the small plastic bottles are 100% recycled plastic, are made out of 100% recycled plastic. But when it comes to plastic, different streams can also be separated and they can generate new small little pellets. And these pellets can be used to create new plastic products. So it goes all the way back to the shops and the industry to use these new recycled products in a circular way. Obviously, at the end of each recycling stream, there is always a little bit of a waste. Depending on what we are recycling, there is always going to be waste, something that is not recyclable. And that at that point, the truck goes to the landfill and unload the final waste, but that waste being a minimal amount compared to the initial waste. In Papua New Guinea, which is the top part of the slide, what you're getting is a combination of the waste streams coming from shop, households, and industry, all collected together into the same bin, if they are collected into a bin. That same bin is then taken by the same truck, and the same truck keeps going and going and going and going all the way directly to landfill. So as you can see, there is a linear trajectory moving from the waste down to landfill, meaning that the recycling effort is zero. So that's more of an indication of a linear economy. And this is what is happening in Papua New Guinea. Now, plastic in landfill, it's quite problematic. On the left-hand side, you can see different streams: construction, demolition material, timber. These are solid, high-density, high mass, low volume type of material. Plastic, on the other side, on the right-hand side of the slide, is a low mass and high volume. So when you have thousands of tons, they occupy a large space, a large volume. And this is problematic in a landfill site because space is valuable and it's not unlimited for sure. Some of the main landfill sites in Papua New Guinea are already full and they are thinking about expanding them to make sure that they have enough to put new waste coming in every day. And that's probably one of the reasons why some of the waste is getting burned directly on site in the open air at the recycling facility. So the waste management in Papua New Guinea can be improved, but what I would like to convey as an idea are these 4 insights here. Number one is that there is a lot of plastic that leaks into the environment. The waste is not captured and it can be captured for reusing. And infrastructure might be one of the avenues, and it cannot be the only avenue, but one of the avenues. There is significant opportunity to divert plastic into construction materials, as I will show you in the next few slides, instead of putting it into the oceans. And the infrastructure sector is emerging as a key end user because of the large volume of material being used when building infrastructure, when building roads, when building bridges, when building curbs and channels and footpaths and airports and aprons and railway. And you will see a few examples later. And number 4 is there is a growing waste of volume. So that means that the supply, the potential supply of recyclable material is not limited. There is as much as we want if we are able to exploit it. So on the good side, on the positive side of the story, you will see that there is this missing link today between the waste and the infrastructure that can recycle the waste, but also the final transport infrastructure that can use the recycled waste. Now, there is a new recovery facility currently being built by the private sector, and the news was that in 2026, this facility will probably process around 10,000 to 14,000 tons of waste per year. and up to 7,000 tons of recycled materials can be engineered for infrastructure use. And this is in Port Moresby, Papua New Guinea. So maybe eventually in the future we will find something that looks like this in Port Moresby, and I really do hope that this is going to happen. Now, that's the figures. That was the picture for what relates to the figures for the waste and the waste management systems in Papua New Guinea and Port Moresby. Let's have a look now at the infrastructure, because that, at the end of the day, it's where we are thinking about using the recycled plastic. Keep in mind, I'm not calling it a waste plastic because we can't use waste or waste plastic in the infrastructure. We need to go through a recycling process first, and I will show you what the differences are. So the road network in Papua New Guinea is not extensive. It's around 10,000 kilometers of primary national road network. In Australia, we have about 800,000, so it's different scale, but it's expanding. The thing is that probably only 1/3, and this was when this report was published last year, so maybe by now the situation can be a bit worse because roads there are deteriorating faster. 1/3 of the roads are in good condition. Most of the national roads are unpaved, meaning that there is no asphalt on top, and only the 2,600 kilometers approximately are sealed type of roads. Now, the thing is that there is a new infrastructure big project, or a big development infrastructure project, that is called Connect PNG program. This Connect PNG program aims to develop and build 16,000 kilometers of roads over 20 years. In addition, there is an upgrade for 9,000 of subnational roads. So as you can see, what is now 10,000 kilometers can easily double or triple over the next 20 years. That means a lot of volume of construction material that needs to be used to deliver this Connect PNG program. At the same time, PNG has got some maintenance and cost pressures. That's because roads are not lasting the time they should be lasting for. Maintenance budget can only cover less than 1/3 of what's required. And there was an estimate that if they want to clear the annual maintenance backlog, they should be spending about 3 billion kina, or 0.8 billion US dollars, to fix the current status of the road. Now, whenever we deal with these big figures, big numbers, obviously there is always a large approximation, but the situation is quite there. So they might need to spend a lot of money that possibly can be allocated to other sectors to fix the infrastructure network. So if we can make it better, that lasts longer and requires less maintenance using recycled material, that can be quite a good outcome for everybody. Now, the road quality challenges in Papua New Guinea are specifically revolving around landslides, erosions. There is heavy rainfall there, as I talk about the wet season, washouts. So it's not uncommon, and I've been there a few times already, it's not uncommon to go there after a rain event and find big puddles all around the main roads, roundabouts being washed away completely within a few months. So it's quite an impressive situation of what the water can do when there is a slope and the quality of the subgrade as well as the road infrastructure is not the way it should be. They also are developing a lot of footpath and urban infrastructure in several cities, Port Moresby, Lae, and other cities. So there is a rapid urbanization. They need to create more footpath, more pedestrian infrastructure, more drainage system, more pavement, and all of that can be taken into consideration, because at the end of the day, we can't just put all the recycled plastic into roads. There are just not enough roads to cope with all of that. We can, though, expand into other territories like footpaths, urban infrastructure, road furniture, and I will show you a few things later, as well as bridges, obviously, with many of them being in poor condition. Now, to close and give you a summary of the transport infrastructure, we looked at the waste before. Now, this is a summary for the transport infrastructure. I summarized here 3 insights. One is that the infrastructure expansion obviously create a lot of demand. There is a need for construction materials, and volumes are quite big. Kilometers and kilometers of roads require cubic meters and cubic meters and cubic meters aggregates, of bitumen, of soil. So the role of the infrastructure is quite massive in the development of a country, but it also requires significant resources. So there is an opportunity there to use recycled materials and to absorb part of the recycled material. The number two is that PNG cannot just keep building new roads and doing maintenance on roads every 6 months, every wet season, every year after the wet season. They need to build something that is longer lasting and reduces maintenance at the same time, reduces maintenance, because this will save budget over the life cycle of the infrastructure, obviously. Number three is that it's not just roads, as I said, with plastic modified asphalt, but you can develop other things out of recycled plastics: geosynthetic for slope stabilization and erosion control, plastic pavers, plastic tiles for footpath. You can develop drainage components like pipes, street furniture, benches, noise barriers, pole, lighting pole, so on and so forth. And I will show you a few of these later. So this is a summary of many applications and product development that have involved recycled plastic in the past, I would say, 5 years across Australia. This is an example of piping for utilities, drainage systems, stormwater collection. You can use it for sewage and roads. You can also use them for agricultural purposes. I put here the name of the company producing it. So if you want more information, you're welcome to go to the website. It's all made out of recycled plastic, as you can see from the multicolored aspect of the piping. Noise barriers for high traffic road. Two types of noise barriers here were developed and tested. There are probably more around the world by now, but it's something that it can be done. It has been done. It has already been applied in the field. And this is how it looks. This is the slat made out of the horizontal slat that you see here. That's a zoom in of that, made out of recycled plastic entirely. And the guy there is measuring the absorption or the reflectance of the noise signal, or the reception of the noise signal, giving a source of noise on the other side of the wall, maybe. So this has been installed, and it's ready. It's shelf ready. You can go and buy it if you need it. Road furniture and lighting. This road pole, it's all made with recycled plastic. The side pole that can produce lights on the street. Plasgain produced it. We have plastic benches. Pretty much every supermarket in Australia has got these plastic benches. Fences for housing. It's all made with recycled plastic. Recently, there was one of the main train stations in Melbourne that has installed recycled plastic railway sleepers, and these are actually, you can see the concrete sleeper on the left-hand side of the top picture, and then all the plastic sleepers being placed by the man there at work on the site. And also recycled plastic blocks if you need to build something lightweight. That was a good option at the time. So it's not just plastic, recycled plastic in roads, but you can engineer waste plastic into a way that makes sense once the product is recycled. So that can generate more avenues for the companies, can increase the business, but also foster a more sustainable infrastructure in a way. Oh, geotextile, I was forgetting about this, but moisture barrier, erosion control, especially in a country where there is a lot of rain and a lot of water is coming up from the bottom all the way to the surface where the road is, having a geotextile that acts as a moisture barrier. This is all made out of recycled plastic. It's called Beating Green, but there are several companies selling similar things for erosion control on slopes and embankments, all the way to substrates for roads, avoiding capillary rise of water. So All of these to just show you two different pictures. On one hand, we got the massive material demand from Connect PNG program and expanding of the city and increasing of the population that requires more infrastructure. And at the same time, we got a lot of that waste that goes into the ocean that is not recyclable, that is not recycled. We don't know what to do. Most of the time, it's just mishandled and put into landfills and burned eventually. So if we could connect the two things together, that would be a very good example of something useful for the country. Not just for Papua New Guinea, but this is a very, very common problem across the Pacific Island nations, across developing countries. It's not just a matter of PNG. I want to be clear about this because PNG is actually a very nice country. So coming to the road environment, plastic in asphalt, how is it working really? I got a lot of questions all the time about will the road look with multiple colors similar to the pipes that you've seen there? The answer is no. The reason being is that we can't just use any type of plastic. As I said, if you are building a plastic bench or a geotextile made out of recycled plastic, you can't just use anything that is plastic because plastic is so different. You go from very rigid plastic that melts at 260 degrees to very soft plastic that melts at 110 degrees. So the properties behind each and every plastic streams are different. And some of these, not all of them, but some of these plastics, they are suitable for modifying asphalt, for modifying the black thing that you see down there when you drive your car on the road. When you add plastic, this particular type of plastic, into the road mix, which is basically made of these stones, aggregate, and the black thing that is called bitumen, the mixing is done at high temperature. It's done at 160, 170, 180 degrees Celsius. So if you're using plastic like this ones that we've used, for instance, in Australia, that melts at around 110 to 140, 150, all of this will be gone by the end of the process. And I will show you an example of this extrapolated from our laboratory. This is the multicolored plastic together with the aggregates. It's all done at high temperature. And what you see is after mixing, there is nothing left of the colors. It's all incorporated together into the same mix. And these already answers a lot of questions around the microplastics generation and all of this. The mix, the plastic doesn't exist anymore in its previous form. It becomes part of the mix itself. And the quantity is very minimal. We're talking about 0.5%, 0.6%, 0.7% of the total waste. But because the infrastructure requires so much material, even a 0.5% is 7.58 tons of plastics per kilometer of road. And I'll show you some statistics later. Obviously, I was only able to show you the laboratory mixing process because you can't put a camera into a large asphalt plant and see what the process, or stop the plant in the middle to take the video. So it would be unsafe. So we've done this in the lab. Now, a few photos. Step number one is just the aggregates being hot into the mixer. Addition of the plastic as step number two. Step number three is the end of the process when everything has been mixed together. So each and every aggregate is kind of coated with recycled plastic that is not multicolor anymore. It's melted and it's creating that sticky effect around the aggregates before the bitumen addition that will convert everything into that black asphalt substance. And this is an example of an asphalt road paved with recycled plastic in Australia. There are many recycled plastics paved roads that have been laid in the past. I think the first one was probably 2018. So it's now about 8 years. As you can see, it's black as usual. Nothing changes. And you can use up to 7.5 tons, so 7,500 kilos of recycled plastics for every kilometer of road. You're usually around 4,000, 5,000 kilograms of plastics for every kilometer of road. Other examples, just to show you that it's not just done in Australia. These are examples from all over the world. And if you want a list of all the countries, you got Canada, you got United States, England, Europe, different parts of Europe. If you want to have the full extensive list, comprehensive list of each and every single place that where this photo was taken, just go to the reference down at the bottom, which I've also put at the end of the presentation, and you can find all the information there so that you can see that all around the world, recycled plastic has been used in a lot of different environments. Now, I would like to say that I didn't think that this was a technical presentation, so I didn't go when I was preparing the slides, I didn't go all the way to put difficult to grasp type of graphs and equations and results from the lab, results from the field, but it is well known now, especially because, as I said, the use of recycled plastic in roads is not something that happened yesterday. We've been discussing about this since quite a while, and we've been using on quite a number of roads that have been monitored over the years now. Plastic in asphalt, if it's done correctly, and by correctly I mean that there is a use of selected recycled plastic, and I'll underline the word selected because, as I said before, you can't use everything you want. The road improves resistance to high temperature. Now, think about this in a PNG environment, in a PNG context where the temperature is actually quite high. There is an enhancement in terms of resistance to cracking. And cracking is the beginning of what a pothole can become later on down the road. Increases asphalt stiffness, reduces fuming and emission at high temperature, does not cause additional harm when it comes to microplastic problems, does not affect the future recyclability of the road materials. Now, if you are unsure about or you want more information about any of these bullet points, just drop me a line or do your research online. There is a lot of material that has already been put out there since quite a while now. In Australia, for instance, I was one of the people who developed specifications for the use of recycled plastic in asphalt. And this was done between the year of 2020 to 2022, 2023. These are national specifications. You can see the suitability of recycled plastic as road construction materials. If you want to download, you can download it for free through the Austroads website. Austroads is the assembly of all the departments of transport in Australia and New Zealand. The release of microplastic from plastic modified bitumen mixes, asphalt abrasion test, that's something that we developed as a first worldwide to find out if there was indeed a need to look at microplastic coming from a recycled plastic modified asphalt, or the guidelines in the state of Victoria to use recycled plastic in asphalt mix. These are just some of the examples, but many other countries these days, they've already got specifications that include the use of recycled plastic. Now, this is quite important because I wanted to stress the fact that we're not using waste from the bin directly into the road, like the image on the left. What we're using does not look like this, a combination of soil contaminated with plastic, contaminated with metal, with pieces of timber here and there, and the plastic is all different species, different types, different shape, different size. This is nothing like what we're doing. What we're doing instead is a well-selected type of plastic, and this can only be achieved if you've got recycling facilities in place. So the final product is nothing less than a standard road made with conventional material. It's actually more than that in terms of performance, quality, and durability. In fact, to get to that point of the small little black pellets, you need to go through a recycling phase. And the recycling phase starts from the collection of plastic, different bins, different colors. The plastic is then sorted. Don't get me wrong, there are countries where plastic sorting is done manually by several people that do that all day, separating different types of plastics. And the recycling is effective. Obviously, it might not achieve the same hourly production rate of a more developed country that is using infrared for sorting or other artificial intelligence type of technologies associated with infrared and other things, but it might still be a starting point. Then after sorting, the plastic is washed and then shredded or grinded and then melted at high temperature, extruded into these small filaments, and then put in a cold water for quenching and then pelletization. I'll show you how it looks like. From the original plastic waste that is baled at the material recovery facility, it gets into the plastic recycling center where it's separated. So you get all the bottles going one side, all the bottles, the plastic lead, the lid of the bottles going on a different sides, because the lid is sometimes is polypropylene, the plastic bottle is polyethylene terephthalate, so PET. So it's all separated. Then it becomes a matter of shredding it into small particles. And after shredding, it's getting washed. Sometimes the washing is done before shredding, but as long as we wash it, it's fine. And then there is an extrusion process, gets into the cold water, and it gets cut into these small little pellets, and that's the final the final product. So processing this highly variable waste, it's very, very important. You can see from the color here, it's a combination of different colors, still the same gradation of gray, but it's a combination of different types of gray. Well, obviously, it's a recycled product. So if you go to a chemical store, a chemical company, and you want a particular type of plastic, LDPE, for instance, in pellet form, you will see that they're all perfectly white because that's 99.999% pure. This is a recycled product, so there might be contamination from this and that because the sorting, the shredding, the cleaning cannot be 100% accurate. But it can be produced with certain tolerances or tolerance values that are suitable for road construction. Going to the road project in Port Moresby and how we use that to implement some climate mitigation strategies. That's related to the fact that the temperature in Port Moresby is rising, and it's rising differently coast versus inner part. But overall, they've got pretty much the same issues as all the Pacific Island countries. Segregation, we went through these 4 different stages in Port Moresby: segregation, processing, supply to industry, and construction. And keep in mind that there is nothing there. So we had to develop everything from scratch, just from literally meetings, phone calls, visit to the plants, and trying to find out what they have, how much they have of this, what the capabilities are, who the main player could be, and put the group together into something that is finally making sense. So as you can see, for the segregation, as I said before, if you don't have automatic machines doing it for you, you need to do it by hand. And this is an example of what is happening and what it has been happening for the past few weeks in the Baruni landfill in Port Moresby. So this is directly from the landfill where the plastic is sorted and divided into different types. We gave them a flyer, some explanation of what we wanted and what we didn't want, and they started separating it into different streams. Waiting at the end of the day, taking notes with the little block notes about how much of each type of plastic was collected. You see they separated the high density polyethylene from the polypropylene, and they didn't find much of polypropylene on that day because it was only 6.54 kilos. As you can see, the date is the 20th of October 2025. So to get to a point where you can make a ton out of it, you might need a few people and a few weeks, but you can get there eventually. And that's how we are building the first roads made out of recycled plastics. So you can see all the plastic caps being separated from the detergents, the shampoo bottles, the dishwashing liquid bottles, so on and so forth. This is a video showing you what they're doing. There is no audio because I muted it, and I'm sorry for the poor quality, but that was sent to me via mobile phone from a person there. But it's basically separating recycled waste plastic by hand and just making sure that only what we require for road purposes is collected. You can see that they've done quite a lot, and it's all separated into different stockpiles. Okay, the second step is the processing. And for processing, there was nothing in Papua New Guinea. So we had to liaise with a company that is called Total Waste Management Group in Papua New Guinea. They had bought This machine, it's one of the first of its kind in Papua New Guinea, and this is basically a shredder. Can take big chunks of plastic and shred it into this minuscule kind of granulate pellet type of form that we can then use further down the track to build roads. So this is how the machine actually works. They usually put their different types of plastic. That's the wheelie bean lead and different containers, water container, shampoo bottles, other type of plastic containers, piping, and different types of plastic material. And what it comes out of it is this little powderish granulates on the right-hand side. I will show that to you again, which is approximately 5 to 8 millimeters inside. So we went above and beyond with connecting these people with the recycler manufacturer that were producing the machine. The private sector bought the machine, imported into Papua New Guinea from Australia. So there was quite a lot of background work to make this happen. And where we're now is we are supplying this product to the industry, and finally we will build the roads hopefully this year. So the idea is to take 2 roads and divide them into different sections. In this case, on the left-hand side, you can see 2 lanes, one left, one right, one plastic modified asphalt, the other one conventional asphalt. The other road on the right-hand side has got 2 different sections, one plastic modified, the other one conventional. The idea was to put together the NCDC people, which are the main people working in the Port Moresby municipality, especially the waste and sustainability team, together with the engineering team, make them talk to each other, which is sometimes is not an easy task. Then get together the industry that can do the cleaning, the reprocessing, and the conversion of what they have collected into a suitable form. Then the department, the NCDC will appoint through tender process the contractor, and everything will be converted into national specification, hopefully down the track, as other countries, including Australia, have already done before. So this is to transform Port Moresby and Papua New Guinea from a linear, if you remember the image of the track going linearly into landfill, to something that resembles more of a circular economy. And if you want more information about phase 1 of the project that has been already completed, you can find all the information here. I put a link there so you can have a look. It has been compiled by Hussein and myself. And phase 2 is the one that is currently ongoing and hopefully about to be finished. So finally, what we wanted to create here was this sort of chain where the Conservation and Environmental Protection Authority in Papua New Guinea, the CEPA, through this private-public partnership for waste management, can put together a group, and the group can then start separating different waste streams rather than just landfilling it, together with the help from some consultants, and this can be transformed into valuable products. And today we've been talking about recycled plastics, but I can produce another presentation on recycled glass, and another one on recycled organics, and another one on recycled vehicle tires. And all of these can be used in the infrastructure, as we have been doing for many years already. Then the thing, once we have waste transform into products, there is a need for policies, for specifications, because if we don't have specifications, we won't be able to use it at the end of the day. But the fact that we have included the main decision makers from the beginning, that will probably facilitate the conversion into national specifications down the track. Field implementation, and then finally international collaborations through the Department of Foreign Affairs and Trade, DFAT in Australia, for instance. There is a very solid and long-term collaboration between DFAT and Papua New Guinea. So all of these can be done with the sponsorship from the ADB as a background agent, as a facilitator of all these steps, as a main facilitator, and probably the most important role out of it in connecting all these small little dots into a long chain that makes sense. Let me say thank you to Hussein, who is the project manager for this particular project by ADB, and Ono-san, who is my field support every time I go to Papua New Guinea and spend some time with Ono, and Ono is taking me around and organizing meetings, and Ono is in Port Moresby and a great person. And the National Capital District Commission and CDC, the City of Port Moresby, and the private sector total waste management that has made all of this possible. That's it from me. Thank you for your time and hope you found this interesting.
Thank you so much for that, Filippo. This presentation that took us through the whole process of what was done in Papua New Guinea. In fact, the tour around NCTC and Port Moresby, that was very insightful. And it was a really quick run through of your hard work over the past few years. So thank you very much for that. We have some questions from the audience, and I hope that you can share some insights. I'm going to start maybe with a simpler question from Prasesh from Isimot. What kind of plastics are used in preparing recycled plastic products such as benches, poles, plastic roads, etc.? And what percentage of this waste plastic is used for recycling?
Yeah, it's a good question that requires a little bit of explanation in the sense that we do have 7 different strains of plastics available, type 1, type 2, type 3, type 4. Each one has got a different name. For roads, what we need is a type 2, type 4, type 5, which is high density polyethylene, low density polyethylene, and polypropylene. For the reasons that I've explained before, they can melt at the manufacturing temperature. So they not stay as a solid particle that might generate microplastic issues in the future. They melt and they are incorporated into the mix without any distinction of what they were before. When it comes to benches, it might be high density polyethylene. And then the other question was about percentages. So in roads, it's usually between 0.1% to 1% of the entire mix design, of the entire asphalt mix. When it comes to benches, or it can be 100%, or sometimes depending on the structural performance, they can go with an 80% recycled material, 20% recycled materials. Road pole, other road furniture can be used with recycled PET, but usually HDPE is a good avenue for creating new plastic products.
Right. Thanks, Filippo. I hope the audience understands plastics enough to make sense of that explanation. But I mean, plastics is all around us. We really should understand these different types a bit better to help in recycling it properly. I'm going to move to the next question from someone working in the Solomon Islands. In the
Yeah.
Solomon Islands, they also face serious solid waste and plastic pollution issues, as with many island countries. According to the city council, recycling costs more, and so they still prefer landfill disposal. So there are two questions here. How can how can we introduce incentives to motivate more recycling of plastics for
Mhm.
the city and private sector to engage in recycling? And what are the key challenges in coordinating among stakeholders to use recycled plastics in road pavement?
Okay, so let's start with the first one about the incentives for the city and private stakeholder. Now, the person, I don't remember the name of the person asking the question, but he or she is absolutely right in the sense that landfilling plastic is way cheaper than going through the process of recycling. In Australia, for instance, you can landfill something for $100, $200, $200. Going through the process of recycling step by step, at the end of the final step, when the plastic is finally ready in a pellet form, you can resell it or you can buy it for $600, $700, $800. So it costs money to the recycler to do the separation, buy the infrastructure, so on and so forth. But it's also true that when it goes into landfill, number one, it's an environmental burden. So you're actually polluting the environment, even if it's in landfill. Landfill doesn't mean you're locking it away in a nuclear bunker and no one will ever touch it. Landfill might still, if it's not done properly, will still leach into the soil and surrounding water and so on and so forth. It smells bad. But the thing is, landfill doesn't produce any value. Landfill actually destroys the value. So one of the incentives is giving the recycling business not to be managed by the city itself, because the city at the end of the day cannot do much with the recycled product that comes at the end other than just building other things for the city if they have the manufacturing industry associated to it. The main incentive will be having the private business to take ownership of the recycling, because they can resell it to other manufacturing companies that can then provide a value to that recycled plastic. So in the sense, if I sell recycled plastics for $600, $700, the manufacturing company that converts that into a bench can sell one bench for $600, $700, and the bench is nowhere near 1,000 kilos of recycled plastic that was the original cost. So for the municipality, recycling is not a great deal, I would say, because they are not making a massive amount of money simply because they don't have all the downstream infrastructure to convert that recycled product into something that they can resell to the users. But to the private sector, it makes still sense getting the waste plastic cheap, converting into something valuable, resell it for 600, 700, giving it to the manufacturer as a supply material, as a raw material, and they can then convert it into something that can cost 3,000, 5,000 down the track, which is also useful for people and humanity in general. So there was a second question related to how to put together all the stakeholders, maybe. That's very difficult. So you need very forward-thinking people sitting down at the table. But definitely my recommendation is to get environmental people, engineers, especially road and infrastructure engineers, the decision maker, people in charge of the specifications, and someone who has got a very solid background on what to do and how to do under a technical perspective, not just using plastic in roads, but also understanding asphalt plants, the way they work, and recycling plant type of technical background, because that is the key person that can join all the other players together
Yeah,
and lead.
definitely. This sounds like a classic case of working across silos, right? Bringing environmental people into manufacturing and infrastructure delivery and working together.
And I can guarantee you that prior to that project, probably they've never talked to each other for this particular reason. Like the waste people have never talked to the engineers that were making roads and vice versa. They
Yeah,
couldn't
and
see
they
the value
probably,
in each other.
yeah, and they speak different languages and value different things for sure. We have now a rather fundamental question, but I think would be insightful for all of us. Can you talk through how you worked with NCDC to explain how the sorting of different types of plastics,
Yeah.
yeah,
So sorting has been done manually. You have seen videos and photos of people at the landfill site putting their effort and time in separating things. So the process is quite slow. On the positive side, Papua New Guinea doesn't it's not very expensive when it comes to labor. So the city was actually paying these people, I don't know exactly how much per day, but for them in a situation where there is no job and high unemployment rates, getting something to do, even for a small amount of money, was quite significant, and they felt like they were part of the solution rather than part of the problem. And that has changed the attitude. And then a few days later, we have more people wanting to join and start sorting and collecting. So in every developing country, I would say that the cost of labor is low and it can be arranged if it needs to be done manually. Otherwise, it's the city or the private sector that needs to invest substantial funds to get machineries.
right. But was it challenging explaining the different types of plastics to people who are not working in this technical field?
Well, we created a flyer which was super simple. Yes column, no column, and all the different pictures. So if it was a plastic bottle, it was a no. If If it was a toy, it was a yes. If it was a part of a car bumper, it was a no. So there were like 20 different, 10 or 15 different images, and it was just as simple as a yes and no.
Okay, so one more question here on the skidding property. How does that compare in a road with using recycled plastic compared with a traditional road?
It's pretty much identical. We did all the experiments in the field and in the lab. There was no change at all in the skidding performance or friction of the road that uses recycled plastic in it. And
Great.
again, if more tangible results are needed, I'm happy to provide any number or precise figure. It's actually all available online. A lot of my projects are all
Right.
freely downloadable.
And I'm going to attempt to answer this next question for you. No, just because I think you mentioned this during your presentation that using recycled plastics increases the durability of the road. Is that correct?
Yeah, that
Yeah.
is compared to a conventional asphalt mix that the city is already using, adding recycled plastic. A lot of people think about recycled plastic as a waste, but if you go deep down, recycled plastic was not born as a waste. It was born like a chemical substance that is used for producing objects, the keyboard, the mouse, the screen, monitor, and stuff. And they all have a stiffness, a resistance to cracking and this and that performance mechanism. So plastic, what we call generally plastic, to me is a polymer. And many things around us are made with polymer, glasses and water bottles and things like that. So they all have strength resistance and different characteristics. So when we're using it into the road, we're not using them as a waste, as a filler that does nothing. We're using them as the original polymer it once was. And that creates that extra benefit, that extra durability. But as I said, it's not the only type of waste that does that. We can get rubber from end-of-life vehicle tires and still use them as polymers. We can get glass. We can get a lot of different waste streams that they were once polymers and structurally sound material and exploit that structural capability in the infrastructure sector.
Yeah, thanks a lot for that, Filippo. I also want to thank the audience for a lot of very interesting questions and a lot of them born from their practical experiences. So this whole discussion has been very grounded in actual practice and helped to reframe waste plastics as a sort of resource that we need for a lot of construction projects that are in the pipeline. So thank you very much for this. And thank you to the audience for your questions. We have in the chat box an evaluation form that we hope you can help fill up. And we apologize for going slightly over time, but thank you very much, Filippo, for sharing your insights and your experiences with us. This has been really very enriching and very enlightening.
Thank you
Um,
for inviting.
Great. And I apologize, we still have some questions we didn't manage to get to, but hopefully we can continue this conversation in different events. We have some announcements.
Hello everyone. This is Mark Agas from ADB. My colleague Christine Lucero just post some links regarding the Green Roads Toolkit and the website, the Green Roads webinar. So if you want to check it, just go to the link. Thank you, everyone.
Thank you. Thanks for joining us.
Thanks. Bye.
Bye. Thanks, Filippo.
Thank you.